Now that we've seen list comprehensions, let's compare them with another style of programming to transform sequences in Python using the filter and map functions. Filter and map are called higher order functions. That is because they can take other functions as input. Let's start with demoing the map function here. So I'm going to start with a simple numbers list. Let's say the numbers here are 1 through 4. And let's also create a function. We call it square, which will basically take a number and it will return that number multiplied by itself, or basically n raised to the power of 2. Now, if I wanted to create another list called squared numbers, I could either create an empty array, then create a for loop, iterate over all of those numbers, and for each of those numbers, I will call the square function. Whatever comes back from that is what I would append into the squared numbers. Or I could create a list by calling the map function. And the map function here takes two inputs. The first is a function, and the second is the array that you wanted to iterate over. So in our case here, the function is the square, and the iterable, or the things that we're iterating over, is the numbers list. Now, if I print out what that looks like, we will get another array of all the numbers raised to the power of 2. Map and filter functions are even more powerful when we combine them with Lambda functions, which is a shortcut or a shorthand version of creating a function. So let's recreate this again, but without having to create a function that we would pass into our map function here. So if I get rid of this square function, over here, I will call Lambda. And what Lambda would allow me to do is basically define, here's my input called n, and the return is going to be n multiplied by n. So this would be kind of like your short version of doing exactly the same thing. Just to prove my point, if I raise this to the power of 3, so this is going to be more of our cubed numbers instead of the squared numbers. Here we get all those numbers raised to the power of 3. So using Lambda function, we can provide a shorthand version of what a function would look like. Similarly, if I wanted to use the filter function, let's create another list of all the even numbers. That would be a list of, we call the filter function. Here I will call the Lambda, where it will take a number. I'm going to call it x right now. And basically the condition that I'm checking for is if the remainder of dividing x by 2 equals 0. So this is my first argument into the filter function, and the second one is the iterable, or the values of, or the list that I'm iterating over, which in our case that is numbers. And so if I print out what this would look like, here we get a filtered list of all the even numbers in my list. Now, these functional tools can feel a little abstract, but they can be very powerful when you use them in a chained pipeline of transformations. But for these simple use cases here, list comprehensions is probably the easier or more clear way to use them. But later on, we'll see how we would be using maps and filters in a much more powerful way.